worked. But cold working changes the mechanical properties of many materials, including steel. If we bend a piece of cold work steel, this is the result. It's lost its ductility and it's become very hard. Now, in many manufacturing processes, we need to be able to bend sheet steel. The body panels of cars are made by pressing out sheet steel in a huge hydraulic press. For this process, the steel needs to be relatively soft and ductile. So, after cold rolling, the properties of the steel must be changed. We do this by heat treatment. It's a process known as annealing. Here, several coils of cold-rolled steel are going to be annealed at the same time. Now, when steel is heated in air to a high temperature, a black oxide forms on the surface. To prevent that from happening, these coils are enclosed in a special jacket. Before heating, the air trapped inside the jacket will be replaced by a gas which does not cause oxidation. Next, the jacket is enclosed in a huge furnace. Steel is annealed first by heating it to a high temperature, just as in hardening. In this particular case, the temperature is set for 680 degrees centigrade. This temperature is held for a specified time, and then the steel is allowed to cool in the furnace. This means the cooling rate is very slow indeed, quite the opposite to hardening. Now, what happens if we try bending a similar piece of annealed steel? It bends without fracturing. By heating and slow cooling, we've restored the ductility and made it softer. Many engineering processes involve cold working a material. Here we're drawing copper tubes. This reduces both the diameter of the tube and the thickness of its wall. In turn, this has the effect of making the tube much longer. That was only one of a sequence of draws needed to get the tube down to the required size. Each draw involves quite a lot of cold working, so you can probably imagine what's going to happen here. To prevent this from happening, we must change the properties of the copper by annealing. This involves heating them in a furnace to a fairly high temperature. For copper, about 650 degrees centigrade. Again, this furnace has been filled with a special gas to prevent oxidization. In the case of copper, we don't have to leave the material to cool in the furnace. It can be cooled quite quickly with water. Annealing has increased the ductility of the copper and reduced its hardness. Now it can be bent without fracturing. However, for many practical applications, this tube is too soft and too ductile. So it's given one final light draw. This will result in a tube that's not too hard and not too ductile. Here's a situation where toughness is an important property. The large steel links used in lifting gear are often made by forging. This can leave the material in a stressed condition, with properties unsuitable for the job it has to do. These stresses can be relieved by another heat treatment process known as normalizing. Again, the steel must be heated to a fairly high temperature. These rings will be left in the furnace for about 2 hours at a temperature of about 900 degrees centigrade. When time is up, the rings are taken out of the furnace and left to cool, this time in air. This not only relieves any stresses in the steel, it also increases the toughness of the steel. Let's compare the toughness of a piece of forged steel before and after normalizing. Here's a piece of forged steel that's been specially prepared for the test. Now, toughness is the ability of a material to withstand shock loading or impact. That had a toughness value of 25 units. Now for the normalized piece of steel. For comparison, the test must be exactly the same. That had a toughness value of about 30 units. Normalizing has increased the toughness of the steel. Heat treatment is one of the most important methods of getting the right properties, especially in steel.